So I'm just going to go through all the questions, fast forward to whichever ones you need to look at, but I'll go through all of them. So for this first question here, it's a complex fraction, so realize this factors to be a plus b, a minus b. And for complex fractions, we want to find an LCD, and the LCD is a plus b, a minus b. So multiply everything by the LCD. And by doing that, we could cancel some of these out. So a plus b, a plus b, a minus b, a minus b, and then everything goes over here. So we're left with 5 times a minus b, so that's 5a minus 5b. Now, I would distribute this negative sign to that 5. This way, you don't forget that you need to multiply both terms by negative 5. So that's negative 5a minus 5b divided by the denominator, we just have 10. So 5a minus 5a, that adds to 0. Negative 5b minus 5b is negative 10b divided by 10, and we're left with negative b. For this next question, we are going to have to factor everything. So let's deal with this first numerator. This is going to be a factor by grouping. So this is where we split it down the middle. So for the first one here, x to the third minus 3x squared, we have an x squared. Over here, 6x minus 18, we could factor out a 6, positive 6. So that's going to be x minus 3. So whatever they have in common, x minus 3, we could factor that out again, goes in one parentheses. The leftovers go in the other parentheses. Okay, so the first numerator is x minus 3, x squared plus 6. The denominator, that's an easy one. That's x minus 4. This next numerator, that's pretty easy too. Factor out a 2, x minus 2. This denominator here, we could factor out x cubed. It's x minus 3. So we have a division sign, so we could change that to be multiplied by the reciprocal. So this becomes the new numerator. So if we're factoring this out, we could do difference of two squares, so that's going to be 4 minus x, 4 plus x. Order matters. Order is important here. And then this will become our new denominator. And that's going to be x plus 4, x minus 2. Now that we've factored everything, we can go ahead and reduce. So let's see. X minus 3, x minus 3, x minus 2, x minus 2, x plus 4, 4 plus x. That could just divide to 1. 4 minus x, x minus 4, we need to take into account that will divide to be a negative 1. And looks like that is pretty much it. So 2 and negative 1 is negative 2 x squared plus 6 divided by x times x to the third, that's x to the fourth. And that's it. We can't reduce any further, so this would be our final answer. If we want to add fractions, we need to make sure we have a common denominator. So first, let's factor our denominators. So 2x minus 3 plus 2, 3 minus x. So it looks like these two denominators are pretty close. The only difference is that this is x minus 3, 3 minus x, but that is important to note. What we can do is multiply one of the fractions by negative 1. So let's go ahead and do that to this second fraction. So the first fraction, that will stay. And what happens here is, I'm just going to do it on the side so that you could see. So if we multiply this second fraction by -1, we will get -3 plus x. But really, that's the same as x minus 3. So essentially, now we have common denominators. And since we have common denominators, we can go ahead and add these fractions. Denominator stays. And we're not done yet. We want to just make sure that nothing is factorable, but the numerator is. So factor out of 3, we get x minus 3. Well, now we can divide these divide to 1, and we're left with 3/2 as our final answer. This was a lot easier than making your LCD 2x minus 3, 3 minus x. If you did that, you still should get the right answer, but it's just going to be a lot harder, a lot more difficult of a problem. So I went ahead and started this problem. What we want to do is find an LCD. So find the least common denominator. So let's see. A minus 3, a minus 3, a minus 2 we need. And we also need an a minus 4. So we need all 3 of those pieces. So that means that our LCD is going to be a minus 2, a minus 3, and a minus 4. So for this first one here, we are missing an a minus 4. So multiply numerator and denominator by a minus 4. And again, that's okay because we're really just multiplying by 1. Next one, we need missing an a minus 2. So multiply numerator and denominator by a minus 2. And the last one, a minus 3. So when we do that, okay, so over here we are going to need to double distribute. So that's a squared plus 2a minus 4a minus 8. And that's all over our LCD, which is a minus 2, a minus 3, a minus 4. Plus, okay, again, we want to double distribute here. A squared plus 2a minus 2a minus 4 over, once again, our LCD. So I'm going to try to speed this up here. Okay. And then our last one, took a little shortcut there. Last one, 1 times a minus 3, that's easy enough, is just a minus 3. Okay, so if we want to simplify this first, that's a squared minus 2a minus 8. This turns out to be a squared minus 4. And this is just a minus 3. So now we can go ahead and combine this into one single fraction. So let's identify our like terms, a squared and a squared. Negative 2a and positive a. And then negative 8, negative 4, and negative 3. So those are our like terms. So let's go ahead and combine that into a single fraction. The denominator will stay as is. And then the numerator now becomes 2a squared. Negative 2a and positive a is negative a. Negative 8, negative 4, negative 3 is negative 15. Unfortunately, we're not done yet because we need to factor the numerator. So I'll do that on the side here. I want to factor by grouping, so 2 and negative 15 is negative 30, And now I need two factors that multiply to negative 30 but add to negative 1, negative 6, and positive 5. So we will go ahead and expand this into 4 terms. Now we can split it down the middle. And this one, we have 2a, a minus 3. Over here, we can only factor out a 5. We get a minus 3. So what they have in common, we can factor out again, a minus 3 and 2a plus 5. So a minus 3, 2a plus 5, all over our LCD. And the last thing is just see if we can cancel anything out. And we can. A minus 3, that divides to 1. So we're left with 2a plus 5 divided by a minus 2, a minus 4. So we have an absolute value inequality. So we'll break it up into two inequalities. 2x minus 5 is less than 1. And 2x minus 5 is greater than negative 1. So switch your inequality sign and negate the value on the right. 2x is less than 6, so x is less than 3. And we have 2x is greater than 4. X is greater than 2. So we'll just quickly put this on a number line. We have 2, we have 3. It would be open circles. X is less than 3, greater than 2. So that means it's going to be a conjunction. That'll be this one right here. What we can do as well is graph this on our calculator. So if we go ahead and put this in y equals, go to math, go to the absolute value bar, 2x minus 5. We want the less than symbol, so let's hit second test. Go down to number 5, and it's less than 1. And then we'll go ahead and graph it. You're going to see that it's shaded in between 2 and 3. And that's exactly what we had when we did it algebraically. So choice 2. Okay, another one here. Let's factor this out to be x minus 3, x plus 2. Let's just make it an equal sign first. Okay, so our factors are 3 and negative 2. So we know on a number line that we're going to have open circles. We just don't know which way we're going to shade. We could test. So you could just test a number in here. So let's test 0. We have 0 minus 6 is less than 0. Negative 6 is less than 0. That's true. So we would shade in the middle. Okay, so you could do the test. If you test it here, it would turn out to be false. This is true. This is false. But again, we can just use our calculator. So let's go ahead and just put this right in. So x squared minus x minus 6 is less than 0. We'll go ahead and graph. And we'll see it's shaded from negative 2 to 3. So from negative 2 to 3, that is choice 2. So we have a patio that measures 6 by 8, but we are going to increase it to a size where the area now measures 150. And we are, if both the width and the length are to be increased by the same amount. So they were 6 and 8, but they're being increased by the same amount. So I'm just going to call that x. So we have 6 plus x, 8 plus x. So what is a number of meters to the nearest tenth that the dimensions will be increased? Well, we know what the area is. We know what the length is. We know what the width is. We just don't know what x is. But we can go ahead and figure this out. To solve area, we do length. So I'm just changing it to x plus 6 times width. And we know that that equals 150. So we'll go ahead and double distribute this. We have x squared plus 6x plus 8x plus 48 equals 150. Combine like terms. X squared plus 14x plus 48 equals 150. Now to solve this, we want to go ahead and bring everything to one side. So when we do that, we get x squared plus 14x minus 102 equals 0. Okay, so now we want to go ahead and factor this. Now, there was a big clue in the question that told me that this was probably not going to be factorable. And the clue here was, what is the number of meters to the nearest tenth? So to me, that means that this is not going to be factorable. And instead, we are going to have to use the quadratic formula. So here's our quadratic formula. In this case, a is 1, b is 14, and c is negative 102. So we just want to go ahead and substitute into our quadratic formula. So negative 14 plus or minus the square root of 14 squared minus 4 times 1 times negative 102 divided by 2 times 1. So let's use our calculator to help us out here. So I'm going to go ahead and figure out what's underneath the radical. 14 squared minus 4 times negative 102. That's 604. So since this says to round to the nearest tenth, so to the nearest tenth, I'm not going to bother to simplify the radical here. Instead, I'm just going to put this all right in the calculator. Negative 14 plus square root of 604 divided by 2. We get 5.28, or 5.3. Now, realize that there's actually two solutions here, plus and minus. Now, if I were to go ahead and figure out with that, instead of doing plus radical 604, if I instead did minus 604, I'm going to get a little bit of a problem here. We get negative 19, and obviously you can't add negative 19 feet or meters. So we're just going to keep 5.3. So now let's see what it asks. It wants to know what is a number of meters that the dimensions will be increased. So that is our final answer. So the dimensions will be increased 5.3 meters. Now we might want to check here, and if we were to make x equal 5.3, that means that this is 11.3. And this is 13.3. Let's just do a quick check, and since we rounded, it's not going to be exact, but it should be close to 150. So 11.3 times 13.3, and that does come pretty close, 150 and 2900. So yeah, our answer is correct. So if we want to simplify this, we would just multiply by the conjugate. So the conjugate is 5 plus radical 7. So multiply by the conjugate of the denominator. So in our numerator, we get 25 plus 5 radical 7 plus 5 radical 7 plus 7 divided by, and when you multiply by conjugates, you really only need to do first, last, last. So 5 times 5 is 25. Negative radical 7 times positive radical 7 is negative 7. Okay, so our numerator would become 32 plus 10 radical 7 over 18, sorry. We could factor out the numerator. 2 times 16 plus 5 radical 7 over 18. And then we can reduce 2 and 18. That becomes 1 and 9. So the final answer would be 16 plus 5 radical 7 divided by 9. There's a few ways that we could actually tackle this question, a few ways to go about it. The first thing that I'm going to do is, okay, if we have anything raised to the negative first, well, can move it down to the denominator and make it a positive exponent. So now we have this. From here, what I might do is think about raising all of that. So if we're taking the square root of something, we're really raising it to the 1/2 power. It's the same thing. Square root is the same thing as raising something to the 1/2 power. Now I'm going to use my power rule here. So a squared raised to the 1/2, multiply the exponents. That's just a. B to the 1/2 raised to the 1/2 is b to the 1/4. So that would turn out to be choice 4. The best course of action to take with this question is to isolate your radical here. So let's move the 2 over to the other side. So subtract 2 from both sides. And now we've isolated this radical. Now the inverse of square rooting something is squaring something. So if we square both sides, those inverse operations will wind up canceling each other out. And we're left with y squared minus 4y plus 4 equals y squared minus 12. At this point, we can bring everything over to one side. So if we subtract y squareds from both sides, they'll just really add to 0. We're left with negative 4y plus 16 equals 0. We could factor. Okay, and we get y equals 4 when we solve it. So if you decided that you instead wanted to do this, that's okay too. You'll still get 4. But we're not done. We do want to make sure that we check. So if we just substitute 4 back into y, we get 4 equals 2 plus the square root of 4 squared, or 16, minus 12. So 4 equals 2 plus square root of 4. 4 equals 2 plus 2. And yep, that works out. So our final answer is just 4. Expressed in simplest radical form. So this is also equivalent to this. Now, I don't know if that helps you out, but we can take it one step at a time now. So we want to do the cubed root of a to the 6th, b to the 9th. So that would turn out to be a squared, b to the 3rd. 6 divided by 3 is 2. 9 divided by 3 is 3. Divided by, and now we need to think of the number that, the cubed root of negative 64. So what number multiply itself 3 times will give you negative 64? That's going to be 4, negative 4. That's 16. That's negative 64. So this would be it. Okay, so we have functions. We have a composition. So we know f of x is x squared, g of x is 2x plus 1. We want to do f of g of x. So first thing we'll go ahead and do is g of x. So g of x. So we're going to take x and substitute it in for x. So g of x turns out to be 2x plus 1. Nothing changes. But now we are going to do f of 2x plus 1. So now wherever we see an x in our f of x function, we're going to replace it with 2x plus 1. So that's 2x plus 1 squared. So 2x plus 1 squared is 2x plus 1 times 2x plus 1, 4x squared plus 4x plus 1 it turns out to be. So choice 4. Inverse. So inverse functions, inverse is when you switch the domain and range, or you switch x and y. So we'll go ahead and do that. X equals 2y minus 3. We want to take a look and just see if that's a choice. Nope, it's not a choice. So all of these are in the form y equals. So we'll go ahead and isolate the y, get in terms of y equals. So we'll add 3, and then we'll divide by 2. So we have y equals x plus 3 divided by 2. We'll see if that's a choice. And it is. Another choice it could possibly be, but it's not, but it could have been this, where it's just broken apart. Okay, we have graph here, and we want to sketch the inverse of this function here. So as I mentioned before, inverse is when we switch the domain and range, or x and y. So what we're going to want to do is maybe just take a few of these points here. So this point is 3, 1. This point here is 5, 3. And we have this point over here. It's like 0 and not much anything else. So I don't know, like 0 and 0.1 maybe. And if we're going to do the inverse of that, we want to switch. Switch x and y. So now that point becomes 0.1 comma 0, 1 comma 3, and 3 comma 5. So we'll go ahead and plot those points. So there's our first point. Here's the second point, and third point is 3, 5. And connecting that, it looks like this. And now remember, a inverse will be a reflection in the line x equals y, or y equals x. And let's just take a quick look. That looks like it was pretty much folded over, so looks correct. And let's just name this function f inverse. This was called f. So this question is asking which one is not a function. And a function is for every input or x value, there's a unique output or a unique y value. So basically it has to pass the vertical line test. That's our quick little way. This here an x squared, so that's a quadratic. Sine of x looks like this. Secant, looks like this. And this would be a circle, looks like this. So basically you need to recognize what each of these graphs look like. You can use a calculator to help you. So needs to pass the vertical line test. This one's good. This one's good. This one's good. The circle, though, that fails our vertical line test. So this is the one that is not a function. Okay, we have a function. This looks like an absolute value function. So y equals absolute value of x. And we want to know which one equation would represent this. So you could easily just use your calculator to help you out with this, but if it's outside the absolute value bar, like these two, it moves up or down, so +1 is up, this one's down. If it's inside the parentheses, +1 is to the left one, -1 is to the right one. So based off of this, this looks like it was shifted up 1 unit, so that is choice 1. But again, you can just use your calculator. Easiest way to do this. Here we have 4 different graphs, and the question is asking us which one of these graphs inverse will be a function. So in order for the inverse to be a function, the original graph has to be 1 to 1. So it needs to pass the horizontal line test. So in order for the inverse to be a function, it has to pass the horizontal line test. So here, nope, that's out. That's out. This one's out, and this one's good. So that's kind of the general rule in order for the inverse to be a function. So this equation of a circle is in general form, and we need to change it over to the standard form. This way we could see the center and the radius. So basically what we need to do is complete the square for our x's and complete the square for the y. So we have to do it twice. So to start, let's group our x's together. Then we'll group the y's together and move the constant over to the other side. So I'm going to start just looking at this here and going to complete the square for this one. So if we were to complete the square, we take half of the b value or half of 16, and square it. So negative 8 squared is 64. So going to add 64 to both sides. I need to add 64 here. Now let's look at the y's. So take half of 6 and square it. So 3 squared is 9. So we're going to add 9 to both sides. So negative 53 plus 64 plus 9. Okay. Now this is a perfect square trinomial. It works out to be x minus 8 squared. And this is another perfect square trinomial. Works out to be y plus 3 squared. And that equals 10. So this just asks us for the center. So the center would be 8 comma negative 3. Okay, we want to write an equation of a circle. So whenever we write an equation of a circle, we need two things. We need the center and we need the radius. So the center's right here. That's great. So that means x minus 8 squared plus y minus k squared equals r squared. So h and k represent the center. So we have x plus 3 squared plus y minus 4 squared. But we don't have the radius. We could easily find the radius though. So this would be the radius. So we just need to find the distance. So we're going to need to use the distance formula. So distance equals x minus x squared plus y minus y squared. You could put 1's here and 2's over here. Okay. So negative 6 plus 3 squared plus 0 minus 4 squared. Negative 3 squared plus negative 4 squared. So that's the square root of 9 plus 16. The square root of 25, which is 5. So our radius is 5, which means it equals 5 squared, or 25. So that would be our final answer. So these choices here are describing the roots. And whenever you see real, rational, equal, imaginary, unequal, you need to think about the discriminant. So the discriminant describes the nature of the roots. So the discriminant is b squared minus 4ac. And that describes the nature of the roots. So if the discriminant turns out to be imaginary, if the discriminant is negative, a negative number, that means the roots are imaginary. If the discriminant turns out to be a positive non-perfect square, so positive non-perfect square, 15, 10, 72, anything like that, be a positive non-perfect square, the roots are irrational and unequal. If we have a positive perfect square, so 25, 36, 64, the roots are rational and unequal. And if we have the discriminant and it turns out to be 0, well, the roots are real, rational, equal. It only hits the x-axis at one point. It's called tangent. So let's take a look here. b is 5, so 5 squared minus 4. A is 2, c is negative 6. So 25 plus 48, and that winds up being 73. So 73 is a positive non-perfect square, which makes the roots irrational and unequal. Okay, let's just do one more. So once again, b squared minus 4ac, negative 5 squared minus 4 times 1 times 1. 25 minus 4 is 21. Once again, that's a positive non-perfect square, so real, irrational, unequal. We're adding complex numbers here. So 4 plus 8i plus 2 minus 9i. So we can add our real numbers and then add our imaginary numbers. So negative 2 minus I. If we were to graph that on an imaginary number plane, negative 2 minus I, it would be graphed like this with the little arrow right here. Okay, that's how you graph complex numbers. That winds up in quadrant 3. So choice 3. We want to write a quadratic equation where the sum of the roots is equal to negative 3 and the product of the roots is equal to negative 9. So we could do this a few different ways. We could either just, we could look at all of these and say, well, the sum of the roots is negative b over a, and the product of the roots is c over a, and we can see which one of these matches. So let's try that way first, and then I'll show you a different way. So first one, we're looking for the sum of the roots to be negative 3. I'm looking for the product of the roots to be negative 9. So right, this one here, negative 3 over 1, that works. But c over a, 9 over 1, we need negative 9. It turns out to be 9. That one's out. Sum of the roots would be negative 12 over 1. Right away, that's out. And this one here, negative 6 over 2. That's negative 3. And the product, negative c over a, or negative 18 over 2. That's negative 9. So it does happen to be this choice. For this one here, you would just have to distribute it out and then check from there. The other way that you could have done it was to use this, x squared minus the sum of the roots times x plus the product of the roots equals 0. So we were told the sum is negative 3, so x squared plus 3x, and the product of the roots is negative 9, so minus 9 equals 0. If we take a look here, that's actually none of the choices. But if you notice, choice 3 is just really both sides were multiplied by 2. So 2x squared plus 6x minus 18, and 2 times 0 is still 0. So you could have done this method too, but just realize that both sides are multiplied by a factor of 2. Okay. Cosine lies in quadrant 2. So we can go ahead and draw out our triangle in quadrant 2. Cosine is adjacent over hypotenuse. So the adjacent is 4, the hypotenuse is 5. So it's a negative 4/5. So if we're going to the left on our xy axes, this would be negative, and your hypotenuse is always positive. So what is the value of tan of theta? Well, tan is opposite over adjacent. So we need to find this opposite side. So we could do the Pythagorean theorem, or just realize it's a Pythagorean triple. This would be 3. Now we're going up on our y-axis, so this would be positive. So opposite over adjacent, so negative 3/4. Whenever we want to express trig functions in simplest form, just try to get everything over in terms of sine or cosine. That's your best bet. So tangent in terms of sine and cosine would be sine divided by cosine. Secant is the reciprocal of cosine. At this point, we have a complex fraction, so we can multiply by the LCD, which is cosine. These all multiply to 1, and we're left with just sine of x. Okay, quadrant 2. So we want to know, in quadrant 2, which trig functions are positive. So this is where we need to use ASTC. All students take calculus. That's an easy way to remember it. So all of them are positive. Sine and its reciprocal are positive. Tangent and its reciprocal. Cosine and its reciprocal. So if we were to just write the reciprocal ones under here, this would be cosecant. So sine and cosecant are positive. Okay, so in quadrant 2, which is what it's asking, sine and cosecant. we want to write an equation based on this trig function. So here's our origin. If it starts at the origin, it's a sine function. If it doesn't start at the origin, then it's a cosine function. So right away we know it's a cosine function. Cosine normally starts above. This one starts below, so it's a negative cosine function. The amplitude. So from the midline, which is the x-axis, to the highest point or the lowest point, however many units it is, that is your amplitude. So 2 units, 2 units, so our amplitude is 2. So we have negative 2 cosine. And now we need to know the frequency. So how many cycles we see from 0 to 2 pi. We only see one, so negative 2 cosine of x would be our answer. So for this one, we want to know which other statement here is true, like which ones are equivalent. So sine of x. Another way we could express sine of x is 1 over cosecant of x. So I didn't do anything, I didn't change anything, it's still the same. This is just another way to express it. Well, let's see if that's a choice. It's not a choice. But if you notice, we have an equal sign. If we cross multiply, we get cosecant of x equals a. So it's choice 1. And these are out because secant and sine, they're not related at all. Sine and cosecant, they are reciprocal functions, so this is the way that you would do it. We have a ride at an amusement park, and it moves according to this trigonometric function. How many seconds does it take the pendulum to complete 1 full cycle? So this here is the definition of what the period represents in a trig function. So 1 full cycle, that means the period. So we have a function here, p of t equals negative 10 sine pi over 3t. So to find the period, it's 2 pi divided by your frequency. So in this case, our frequency is pi over 3. So 2 pi divided by pi over 3. When you go ahead and do that, you wind up getting 6. So if you're having trouble with dividing fractions, just put in your calculator, you'll get 6. Which graph represents a sound wave that follows a curve whose period is pi, and that is in the form y equals a sine of bx? Well, right away we can get rid of choice 1, because this is a cosine curve. It has to start at the origin. So the period needs to be pi. So that means where 1 full cycle ends. So I'm going to write that down over here. When 1 full cycle ends. So a full cycle of sine looks like this. Goes up, down, starts back at the origin. So that needs to end at pi. Let's take a look here. So here's 2 pi. So that must mean that this here is pi. 1 full cycle, yep, that ends at pi. So it is choice 3. Let's just go ahead and look at the other ones, why they don't work. 1 full cycle ends at 2 pi. So that means the period here is 2 pi, but we want it to be pi. And this one here, 1 full cycle ends right here. This would probably be pi over here. So this one, the period ends before pi. So this one's out as well. We have a circular walkway, and Jack wants to plant flowers in the shape of an arc. So something maybe like this. If the circle has a radius of 5 yards, and the angle subtended by the arc is 1.5 radians. So this angle is 1.5 radians. What is the length in yards of the border? So x. So this is a classic S equals theta r problem. S stands for your arc, theta stands for your angle in radians, and r stands for the radius. So we're in good shape because the angle already is in radians, 1.5 radians. So S equals 1.5 times 5. And my S's look like my 5's. All right. Try to do a better one. There we go. S equals 7.5. 1.5 times 5 is 7.5. Okay, so we want to write an equation of this trig graph here. And this is that real world one. Here we have time in hours, humidity. So first thing we want to do is identify the midline. So midline is right here. So that's at 55. So if we know the midline is 55, that means at the very end, we are going to have a plus 55. It's shifted up 55. So looking at the midline here, let's determine if it is a sine or a cosine curve. So if the graph starts at the midline, then it's a sine curve. So we know it is a sine graph. Let's figure out the amplitude next. So from the midline, which is 55, to the highest or the lowest point, we want to know how many units that is. So from here to here. So 55 to 80 is 25 units. So the amplitude is 25. So A equals 25. The last thing we want to know is our frequency. How many cycles we see from 0 to 2 pi. But we have a problem because there's no pi's on our x-axis here, because this is our real life one. So instead, let's figure out the period. So the period of this graph, and that means when one full cycle ends. So one full cycle ends at 24. So the period is 24. Well, how do we get the period? We do 2 pi divided by frequency. So 2 pi divided by some value gives us 24. So we can cross multiply. 24b equals 2 pi. So b is going to equal pi over 12. So our frequency is pi over 12. So putting it all together, y equals 25 sine of pi over 12 x plus 55. So amplitude, frequency, shift. Solve algebraically. So let's get these to be common bases. So between 9 and 3, hopefully you realize that your common base would be 3. So 3 squared, that still gives us 9, so we're still good. So 3 squared raised to the 3x equals, we don't need to change this one. So now we have 3 to the 6x equals 3 to the 3x plus 1. Now we can just set our exponents equal to one another. So 6x equals 3x plus 1. 3x equals 1. X equals 1/3. Okay, so logs, we want to solve for x. Can't do anything any further, but what we can do is change this over to exponential form. So 8 to the 2/3 equals x plus 1. 8 to the 2/3 equals x plus 1. So 8 raised to the 2/3 is 4. 4 equals x plus 1. X equals 3. So now whenever we have logs, it's always a great idea to check. So log 8, 3 plus 1 equals 2/3. And 8 to the 2/3 equals 4 if we were to convert it back, and that does work. Okay, we have a population of bacteria, and the population, it grows exponentially according to this formula here. So we want to know how long it will take for the population of bacteria to reach 51,200. So 100 is the initial, so that's stated in the formula. We want to know how long will it take for the population to reach 51,200. So we want to isolate the exponent. So divide both sides by 100. 512 equals 2t. So we can do one of two things. We could try to get them to be the same base, or we can convert it to log form. So if we convert it to log form, log base 2 of 512 equals t. And at this point, we can use our calculator. So math, scroll down to log base. And we get 9. So t equals 9. The other way you could have done this was try to get them to be the same base. So 512 is 2 to the 9th power. Now that they're the same base, 9 equals t. So 2 different ways to do it, you'll get the same answer. We want to know which expression is equivalent to this one right here. So it looks like we need to condense. It's expanded out, so let's condense. So number in front, the coefficient, will become the exponent, so the power rule. So we have log m to the 1/2 minus log n to the 3rd. Okay. Now we have subtraction, and that will condense to division. So we want to condense to one single log, m to the 1/2 divided by n to the 3rd. So just realize that you probably won't see a fractional exponent. It will be represented as a radical. So really that's the same thing as log radical m divided by n to the 3rd, which is choice 4. We have interest, and it is compounded monthly. And what's nice is that we have the formula right here that we're using. So P represents the principal amount, R represents the rate, N is the amount of time it's compounded, and it's monthly, so 12 times a year, and T is time. So really all that we have to do is substitute our values into our formula. So she initially invests $5,000 into the bank. And we want to know how long does it take for it to double, so for it to reach $10,000. So she wants $10,000. Goes right here. She initially invests $5,000 at a rate of 6%, so 0.06, and it's compounded monthly, so divided by 12, and 12t. So t is left as the variable because that's what we're looking for. We're looking to see how long it takes. So the first thing we could do is divide both sides by 5,000. So our goal is to try to isolate that t. Okay, so we have 2 equals 1 plus 0.06 divided by 12 raised to the 12t. Let's simplify what's inside the parentheses. So 1 plus 0.06 divided by 12. Okay, all right. So unlike the question a few problems ago, we can't get these to be the same base. It's just not possible. So instead, what we're going to do is convert this to log form. So the base of the exponent is the base of your log of 2 equals 12t. So we'll evaluate this, and then to get t by itself, what we're going to have to do at the very end is divide both sides by 12. So if we want, we could just go ahead and put this whole thing in our calculator as we see it. That might be the best way to do this. Okay, so it's going to be a fraction. So log base 1.005 of 2, and then whatever that is, we're going to divide by 12. That turns out to be 11.58. So, whoops. T is 11.58. Let's see what the rounding directions were. How long? To the nearest tenth of a year, sorry. Nearest tenth of a year. So 11.6 years. Simplify this expression. So if we want, we can go ahead and use our power rule. When we have an exponent raised to another exponent, we multiply. So when you multiply fractions, multiply straight across. Again, you can use your calculator if you want. You get -4. So all this becomes m to the -4th. So 6 raised to the m to the 6 raised to the -2/3 is m to the -4th. But we want to write it using as a positive exponent, so it's really 1 over m to the 4th. Solve for x, so logs here. Let's condense to be one single log. So when we have a subtraction, we can condense that to be division. So log base 3 of x squared minus 4 divided by x plus 2 equals 2. So we could actually factor this out early. That will save us an extraneous solution here. So really we're just left with x minus 2. Okay, so if we factor early on in the beginning, that might help us out because we'll get rid of a rejected solution. At this point, let's convert to exponential form. So 3 squared equals x minus 2. 9 equals x minus 2. And x equals 11. So it's a good idea to go back and check. You can put this all right in your calculator, and it should get 2. Maybe we'll go ahead and do that. So if we were to check log base 3 of 11 squared minus 4 minus log base 3 of 11 plus 2. And that should equal 2, and it does. So this answer we could accept. Okay, so that's it. So this doesn't mean that it's limited to these questions. There could be other questions, so make sure you look at your Regents review and go from there. But this is a good idea of some questions that could be on the quarterly.